Hello there, Mr. Sutton here, bringing you the IM3 Honors 4-1 Extra Practice Solutions on solving quadratics by factoring. To solve this equation by factoring, we need to move this 3x over to the left side to be with the x squared. That'll leave 0 on the right side. And now we just have to factor this as best we can. Now I see that I only have two terms, and they both have x's in them. So let me take out a common factor of x, and that leaves me with an x minus 3 in parentheses. And now setting each of these factors equal to 0 and solving, I see that if I have an x value of 0 or positive 3, either of those will zero out one of these factors and solve my equation. To solve this equation by factoring, I first check to make sure I've got everything in order on one side, and it looks like I do. We have 0 on the other side, so now we just have to factor this and set each factor equal to 0. So this has an a value of 1, so I can just look at factors of 40 that add up to 13. Well, let's see here. We've got 1 and 40, that doesn't work. 2 and 20 doesn't work. 4 and 10 is better, but still not quite what we need. If I had 5 and 8, positive 5, positive 8, those add up to 13. So then I can factor this into x plus 5, parentheses x plus 8. And now setting each of these equal to 0 and solving, if I have an x value of negative 5 for this first parentheses, or negative 8 for this second parentheses, both of those would zero out a factor and solve my equation. For this problem, I'm trying to solve by factoring. To do that, I need to have everything over on one side. So let me add this 49 over to the left side, leaving 0 on the right. And now I just need factors of 49 that add up to 14. Well, 7 and 7 seems to work, so I can write x plus 7 squared, since there's two of these factors of x plus 7. And then I just have to set one of these x plus 7s equal to 0 and solve. And if I have a value of negative 7, that would zero this out. So negative 7 is my only answer. To solve this equation by factoring, I need to get that 42 over to the left side. I'll do that by subtracting it. Now that I've got 0 on the other side, I can factor the left side and set each factor equal to 0. So now I need factors of negative 42 that add up to negative 1. So what are our choices? We've got 1 and 42, definitely won't work. So 2 and 21 also is a dead end. 3 and 14, not even close. 4 doesn't go into 42. 6 and 7. Well, if I had positive 6 and negative 7, that would add up to negative 1. So then I can write x plus 6, x minus 7 as my factors. And then setting each of these equal to 0 and solving, I see that x equals negative 6 for that first one, and positive 7 if I add 7 for that second parentheses. On this problem, to solve by factoring, I need to subtract 64 from both sides. Now that I've got 0 on one side, I can factor the left side. This is a format of a squared minus b squared, a difference of squares. So it can be factored into a plus b, a minus b. Square rooting these two things, that means we have x plus 8 and x minus 8. And then setting each of those equal to 0 and solving, we have x equals negative 8 for that first parentheses and positive 8 for the second parentheses. And again, we're just picking values of x that zero out each parentheses. To solve this equation, I'm going to add this 126 over to the left side so that I've got this thing zeroed out. And now that I've done that, I'm going to try factoring it. Now, I notice that I have an a value that's not 1 right here. So let me see if I can take out a common factor. 6, 60, and 126, those are actually all divisible by 6. So if I take out that 6, that leaves me with an r squared, plus this will be a 10r, and then 126 divided by 6, well, 120 divided by 6 is 20, so this would be 21 then. And I'm going to try to factor the inside a little bit more. So I've got factors of 21 that add up to 10. That's what I'm looking for. Well, your only choices are 1 and 21 and 3 and 7. 3 plus 7 adds up to 10. So I can bring down this 6 and I can break up this parentheses into r plus 3 and r plus 7. And now setting each of these factors equal to 0 and solving, note that this 6 out here doesn't really do anything because it's not a variable. However, if r plus 3 equals 0, that means r could have a value of negative 3. And if r plus 7 equals 0, that means r must also have a possible value of negative 7. To solve this equation by factoring, I need to get everything in order on one side. So on the left side here, first I'd like to write this 9r squared first. And then this 5 will come sometime after. I need to also get this 46r over to the left side. So I'm going to add the 46r over to the left. So I'll write plus 46r. And then this plus 5 is on the end of all that on the left side. And on the right side, we have 0. All right, now I'm going to try to factor this. I happen to notice that we have an a value that's not 1. And I can't take out any common factors to fix that. So I'm going to factor this using the AC method. So if I do 9 times 5, that gives me an AC value of 45. And now I just need factors of 45 that add up to 46. Well, how about 1 and 45? 1 plus 45 equals 46. So I'm going to split up 46r into 1r plus 45r. And now that I've got 4 terms, and let me write equals 0 there. There we go. Now that I've got 4 terms, I'm going to factor this by grouping. So for the first 2 terms, I can take out a common factor of r, leaving me with 9r plus 1. For the second 2 terms, I can take out 5, leaving me with 9r plus 1. And now factoring out the 9r plus 1, that leaves me with another parentheses with an r plus 5 in it. Setting each of these equal to 0 and solving, for this first parentheses, if 9r plus 1 equals 0, if I subtract 1 and divide by 9, I get r equals negative 1 over 9. And for the second parentheses, I would have to subtract 5, so we get r equals negative 5 for that second factor. For this problem, they want to know by what amount does the sum of the roots exceed the product of the roots of this equation. Well, in order to figure this out, we need to know what the roots are in the first place. Since this equation already is all factored out with 0 on one side, we just set each of these factors equal to 0 and solve. So that means that x is going to equal 5 for zeroing out that first parentheses, or negative 2 to zero out that second parentheses. And now we need to know what the sum and the product of these 2 roots are. The sum is what you get when you add these. So 5 plus negative 2, or 5 minus 2, is going to give us 3. The product means multiply them. So we have 5 times negative 2, giving us negative 10. And now we want to know by how much the sum exceeds the product. So basically we just have to do sum minus product. So 3 minus negative 10, that's really 3 plus 10, leaving us with 13. For this problem, we're given that p equals x times 3x plus 5 minus 28. We want to know which of these factors p is divisible by. Well, in order to figure out what p is divisible by, it would help to know what the factorization of p actually is. Because this is not really factored. I mean, it's kind of sort of partially factored, but the whole thing isn't factored. So let's go ahead and put this in standard form and factor it. So we have x times 3x. Now we're distributing this x here. That'll be 3x squared plus x times 5 is 5x. And we still have that minus 28 hanging around on the end. I'm going to go ahead and factor this now. But I notice that I have an a value here that's not 1. And I can't take any common factors out of all this. So I'm going to use the AC method to factor this. We've got 3 times negative 28 for the AC value of, let's see here, that's going to be negative 84. Now I need factors of negative 84 that add up to 5. And this is a little bit tricky, but let's go through them. We've got 1 and 84, not even close. 2 and 42 won't work. 3 goes into this 28 times, though, so 3 and 28 is not going to give us a 5 by adding or subtracting. 4 goes in 21 times, still not going to get a 5 out of that. 5 doesn't go into it. 6, does 6 go into this? 6 goes into this, let's see, I think 14 times. Is that right? We've got 6 times, yeah, 6 times 14 would give us this, but that's still not going to help because the best you could do out of that is like an 8, not a 5. How about 7? Does 7 go into this? Well, 7 goes into 70 10 times, so it's going to go into this 12 times. 7 and 12, can we get a 5 out of that? If we had negative 7 and positive 12, that would work. So I'm going to split this up into negative 7x plus 12x. And now that I've done that, with these four terms, I can use factoring by grouping. For the first two terms, we can take out an x, leaving us with 3x minus 7. For the next two terms, let's see, those are both divisible by 4. So take out a 4, leaving us with 3x minus 7. And now since I have a 3x minus 7 repeated, I can take that out as a common factor, leaving me with an x plus 4 as my other factor. All right, so divisible, p is going to be divisible by one of its factors, right? Because if p is the product of two things, that means it's divisible by both of those things. If you divide by one of the things, you get the other thing. So p is going to be divisible by 3x minus 7 or by x plus 4. It's divisible by both. Now looking at our answer choices, the only one of those that is listed is 3x minus 7. So we're going to have to go with choice D.